Today we're going to be going over your study guide for tomorrow's test. So I would suggest gathering all of your notes from this quadratic functions unit, as well as keeping this sheet safe somewhere. Now we're going to get started, and one of the questions might ask you to label the parabola. So we're going to label the parabola. We're going to use all or some of these vocab words that are provided. So an axis of symmetry, you're actually going to have to draw the axis of symmetry. So remember, the axis of symmetry is right through the vertex, and it's the center of our parabola, where our parabola essentially is perfect on both sides, the same distance away from the axis of symmetry. So on your paper, you're going to have to draw it and label it. And you can label it however you want. You can actually label it on the line like I did, or you can label it down here next to the arrow. Now I've got that checked off. Our vertex. Our vertex is how the lowest or highest point of our parabola. Well, our vertex is going to be right here. And I actually want to know what the number is, which is 1, -4. So on your test, make sure that you write what the vertex is. Now I'm going to look and see if I have any x-intercepts. Our x-axis is here, which is horizontal, so I'm going to see if our parabola hits anywhere on our x-axis. Oh hey, it hits right here and right here. And I'm going to make sure I write what the x-intercept is, which is 3, 0. And over here is also my x-intercept. So sometimes you might have 1 on your test, you might have 2. In this case we have 2, which is -1, 0. Our x-intercepts are some number with our y being 0, and our y-intercepts are going to be 0, comma, whatever number. So remember, y-intercepts, the x is 0, x-intercept, the y is 0. So I actually do have a y-intercept for this one. It's right here, and I'm going to label it 2. So this is going to be 0, -3 for my y-intercept. Oops. Now I need to know if it has a maximum or minimum, meaning is it concave up, concave down, and if it has a maximum or minimum. Remember that a minimum is a concave up type of parabola, which is going to be the lowest point, minimum point. Our maximum is going to be concave down, and it's going to be the highest point that our parabola reaches. So in this case, I have a minimum, I don't have a maximum. So, and minimum. And our minimum is going to be right there. Oh, our axis of symmetry, I forgot to label, is x equals 1. Sweet. All right, let's move on. So we identified each part of the parabola. This can definitely help, especially if you're looking at formulas and trying to figure, parabolas, and trying to figure out what the heck the x-intercept is, what the y-intercept is, and if there's a vertex or not. Obviously there is, but you know. So now we're going to identify its concavity, vertex, x and y intercepts on the graphs. So our concavity means, is it concave up or down? As I can see, this is a concave up type of parabola because it's facing upwards. Our vertex, remember this is a point on our parabola. vertex, I can look for the axis of symmetry, which I know my axis of symmetry is x equals 2, so my vertex is going to be this point right here. So my vertex is 2, negative 3, because it's right in the middle of my parabola. My x-intercepts. Well, do I have any x-intercepts? Absolutely. I have one right here and one right here. So if there's two x-intercepts, you need to include both of them. If there's only one, then there's only one. And now I have my y-intercepts where it hits my y-axis. Oh, hey, look, it's the same point, which is totally acceptable. I can have an x and y-intercept that are the same. And this would all be worth points if you got it correctly for all parts. So make sure you include, if it's asking what its concavity is, what its vertex is, the x and y-intercepts. Remember, you have to include that they're points. So we're going to do another one. We're going to do the exact same thing. Well, it's concavity. I know it is concave down because it's facing down. So on my test, I would write concave down. The vertex, well, let's see. I know my axis of symmetry is right in the middle here at x equals negative 3. So my vertex is actually going to have a maximum. And this is going to be my point here, which is negative 3, 4. Remember, x comes first and then y comes second with a point. Ooh, do I have an x-intercept? Well, let's see. If I follow my parabola or even my x-axis, I can see it hits here and here. So one of my x-intercepts is negative 1, 0, and my second one would be negative 5, 0. Now my y-intercept, I'm going to follow along my y-axis here. Oh, hey, look. Boom. I have a y-intercept of 0, negative 5, because on my x-axis, I'm not moving anywhere left or right starting at 0, 0. I'm just moving down. So now let's practice more problems here that might be on your test. Now our factored form formula, remember, is y equals a parentheses x minus r1 and parentheses x minus r2. Remember that both of these r's are just a placeholder. So remember, let's see, there we go. So this a tells us if there's any indication if it's positive or negative, or any number that tells us where to move about the parabola. What I would do underneath it, I would write an example of y equals x minus 2, and let's see, x minus, let's do 4. So if I have the factored form, this is what it would look like in a real life situation. This is before we move to standard form. This is what this step looks like. It's right before we have standard form. Now remember, our standard form now is y equals ax squared plus bx plus c. And if you can recall, our c here is actually our y-intercept where it hits our y-axis. Our a tells us if it's concave up or down. And the b tells us what our factored form is. So if I was actually going to solve out this y equals x minus 2, x minus 4, if I distributed, I would get x squared, or sorry, FOILed, or distributed, minus 4x, negative 2x, and then I would have a plus 8. So my final standard form would look like this. X squared, combine like terms, negative 6x plus 8. So that would be my final equation in standard form. So we use standard form to graph, we use it to understand where our y-intercept is, how it concaves, and where it's going to hit our x-axis as well. So now we're going to put the following equations from factored form into standard form. So remember, this is just FOILing. So if I have x times 11x, that's going to be 11x squared. And then I would take my x and multiply it by my 10, and I'd get plus 10x. And do the same thing here. Take my 6 and multiply it by 11 to get 66x. And then 6 times 10 is 60. And now to finish it into standard form, I need to make sure I combined like terms. So I can combine my x's here, and everything else is just going to come straight down. And there we go. There's our standard form. So let's try the second one here. We're going to do, again, 9 times x, giving us x squared. X times a negative 9. Okay, interesting. And then I have 9 times 9 times x, which gives me a positive 9. And if I multiply those two, I'm going to get a negative 81. Combine like terms, 9 and 9 cancel out, so I'd actually be left with x squared minus 81 would be my final answer. So now we practice from factored to standard form. We're going to try again. So I want you to pause the video and fill it out yourself. So this is what you should have gotten so far. 8x squared plus 16x minus 4x minus 8. So if I combine like terms, 16 minus 4 is going to give me a positive 12x. And to the last one now. The final answer you get is negative x squared minus 21x plus a 396. So now that we've practiced factored to standard form, now the last one is standard to factored form. Well, let's see. If I only have my y-intercept here, based on the last one we know, I need to first know the factors of 9, which are 3 and 3 and 9 and 1. Now I have my x's here, because remember we need to write our x's first. I know that it's going to be a minus 9, meaning that one of the symbols is positive and one of them is negative. Well, let's see. If I factor these out, if I do 3 minus 3, that will give me 0. That means my x's in the center will cancel out. If I did 9 minus 1, that would only be 8x in the center. So I know that this has to be positive 3 and negative 3. Now for this one right here, the factors of 10 are 10 and 1, and I have 5 and 2, and that's it. So now I can factor. Since I have a negative 10, one of the symbols needs to be positive, one needs to be negative. So if I do 10 minus 1, that only gives me 9. I'm looking for a negative 3 in the center. So if I flip them around, I still get negative 9. So let's do 5 minus 2. So positive 5 and a negative 2 give me a positive 3. But if I flip it around, if I make it a positive 2 and a negative 5, I get a negative 3. So I need to place my negative 5 here, or sorry, my 5 here and my 2 there to get my final answers. Now the last two here, I want you to pause and do on your own, and then I'll show you what the answers are. Alright, so for the last two here, your factors of 28 were 4 and 7 and 28 and 1. So they both had to be negative based on this positive number here and this negative 11. So when I added two negatives together, I got negative 11 and negative 29, meaning that 4 and 7 were the factors. Now for this one, I add a bunch of different factors, but it's going to be 9 and 4. You can pause the screen now to see.